Now, yesterday we saw how to solve a system, finding the point of intersection by graphing the two equations. Today we're going to see how do we solve it algebraically without having to graph the system. And this one technique we're about to see is called elimination method. And the steps are listed here. We'll see them in action in just a second. First step, multiply one or both of the equations by a number that will result in the two equations containing opposite terms. After that, we add the equations together, hopefully eliminating one of the variables. We solve the resulting equation, substitute the variable that we solved for, and then check it in the original system. Let's see what that looks like. So first of all, let's start with this one, writing and solving a system. The sum of two numbers is 5, their difference is negative 19. Find the two numbers, write a system, and then solve using elimination. Okay, so let's start with the first equation. The sum of two numbers is 5. Okay? So the sum of two numbers is 5. So the first number is x, the second number is y, their sum is 5. Alright, so our first equation is x plus y equals 5. Our second equation, actually let me put that somewhere else, because I'm going to need that space to do work. So my first equation is x plus y equals 5. My second equation says that the difference of the numbers is negative 19. So x minus y equals negative 19. Alright, so to use elimination method, we want to add these equations together and make one of the variables eliminate when we do that. And for that to happen, the variables have to have opposite coefficients. They have to be opposite. And in this equation, the x's are the same, but the y's are opposite. Positive y and negative y will cancel when we add them together. So let's look at what it looks like when we add equations together. So we have x plus y equals 5, and we have x minus y equals negative 19. And we're just going to add this like any normal equation. X plus x is 2x, positive y and negative y is 0, and 5 plus negative 19 is negative 14. So our resulting equation is 2x equals negative 14. And now we can solve this for x. So one step to solve for x, divide by 2, and we see that our x is negative 7. Now this is only half of the answer. This tells me that where these two lines intersect are going to have an x coordinate of negative 7. But we still need the y coordinate, which means we need to go back to one of the two equations and substitute this x in to find y. So I'm going to substitute this into equation 1. Equation 1, x plus y equals 5. So negative 7 plus y equals 5. And I want to solve this for y this time, because I already have x, I want to solve this for y. Add 7, and I'll get y is equal to 12. So the ordered pair where these two lines intersect is going to be negative 7, 12. And I do want to check that in both equations. The sum of two numbers is 5. Negative 7 plus 12 equals 5. That's correct. It works for equation 1. The difference is negative 19. Negative 7 minus 12 equals negative 19. That's also true. So this equation, or this ordered pair, works for both of these. And I've just solved these. I've just found out where these two lines cross without having to graph the lines. But if you did graph the lines, you'd get the exact same solution. Now, on that first problem, we didn't have to do anything to the equations to make them eliminate when we added them together. Alright? But on this next one, you'll see that that's not going to be the case, because you'll see if I try to add these as they are, 5 and 8, that's 13x, plus 6y equals negative 44, which nothing canceled out. That's not going to work. So I'm going to have to change one of these equations, multiply them by something, either both of them or one of them, by a number, so that when I add them, something will cancel out. So I see that these y's, they have the same number, 3 and 3. If I can make one of the signs opposite, if I can make one of them negative 3, then they'll cancel when I add them. So what I'm going to do is I'm going to multiply the first equation by negative 1. And that's going to give me a new equation. Negative 5x minus 3y equals 19. And I'm not going to do anything to the second equation. That's going to stay. 8x plus 3y equals negative 25. But you'll see here, when I add them together now, I'm going to get something to cancel. I'm going to get the y's cancel. Negative 5x plus 8x is 3x. Negative 3y and positive 3y are going to cancel out. And then 19 plus negative 25 is negative 6. And I can now solve this equation. I got 3x is equal to negative 6. I can now solve this for x. Divide by 3. X equals negative 2. So the x-coordinate where these two lines intersect is negative 2. But I still need the y-coordinate. So I can plug this x-coordinate into either one of these equations to get the y-coordinate. So I'm going to go ahead and plug it into the first equation. 5x plus 3y equals negative 19. So 5x, well wait a minute, x is, I know what x is negative 2. So 5 times negative 2 plus 3y equals negative 19. So that gives me negative 10 plus 3y equals negative 19. I can solve this for y. I'll add 10. So I'm going to get 3y equals negative 9. I'll divide by 3, and I'll get y equals negative 3. So the ordered pair where these two lines intersect is going to be the ordered pair negative 2, negative 3. And this is going to be my solution. This is going to be the solution to where these two lines intersect each other. Of course, you do want to check it for both equations. Okay, so I plug it in. 5 times negative 2 is negative 10, and 3 times negative 3 is negative 9, and negative 10 plus negative 9 is negative 19. I can do that for the second equation as well. I've got 8 times negative 2, which is negative 16, and I've got 3 times negative 3, which is negative 9, and negative 16 plus negative 9 is negative 25. So this ordered pair works perfectly. That will be my solution. Negative 2, negative 3. Now this one, it looks like we're going to have to do a little more work. The first equation, x plus 5y equals 3. Second equation, 3x minus 2y equals negative 8. Alright, none of these are the same. They're not the same number. We can't add them. Nothing's going to disappear. So we're going to have to change it so that the equations will have variables that disappear. So I'm going to look at these x's. These x's look nice. I've got a 1x and I've got a 3x. Now if I can turn this 1x into a negative 3x, then it will cancel with this positive 3x. So I'm going to multiply this first equation by negative 3. And what that's going to do is it's going to multiply everything by negative 3. It's going to be negative 3x minus 15y equals negative 9. And the second equation I'm going to leave the same. And the reason is because now I have variables that will cancel when I add the equations. These x's will cancel when I add the equations. If I add these equations, negative 3x and 3x cancel out. Negative 15 plus negative 2, negative 17y, and negative 9 plus negative 8 is negative 17. And now I can solve this for y. Divide by negative 17 on both sides, and it looks like my y coordinate is positive 1. So that's only half the battle. I know what the y coordinate is, I still need the x coordinate. So I'm going to plug this y coordinate, I'm going to substitute it into the first equation. And that's going to tell me what the x coordinate is. So I have x plus 5 times y, which is 1. So 5 times 1 equals 3. So x plus 5 equals 3. So this is just a one-step equation to solve this for x. I'm going to subtract 5. I got x is equal to negative 2. So the ordered pair where these two intersect is going to be the ordered pair negative 2, 1. These two equations, these two lines will cross at negative 2, 1. I do want to check this for both of them. Negative 2 plus 5 is 3. Okay, that's correct. And then negative 6 minus 2 is negative 8. And that's also correct. So this works for both of my equations. Let's look at one more, and this is going to be kind of how most of the word problems are. Ali bought 3 notebooks and 5 pens for $13.75. At the same store, Tom bought 4 notebooks and 6 pens for $17.50. Write a system to find the cost of each, and we're going to use N for notebooks and P for pens. So Ali, Ali had 3 notebooks plus 5 pens, and that cost her $13.75. And then Tom bought 4 notebooks and 6 pens, and that cost him $17.50. Alright, so we are going to have to change not one of these equations, but both of these equations, because there's no way to make 3 and 4 the same, or 5 and 6 the same, without changing them both. So what I'm going to do is I'm going to work on this 3 and the 4. If I can make one of these 12 and one of these negative 12, then they will cancel out. So I'm going to multiply this first equation by 4. And that will make the first equation 12n plus 20p equals, and well, I probably should have my calculator out for this one because I will need it. So I have 1375 times 4, and that's 55. So this will be 55. Okay. Now let's move to the second equation. I need that 4. I made the 3 into a 12. I need the 4 to be a negative 12. So I'm going to multiply this by negative 3. So I have negative 12n minus 18p equals, and then I need to get out my calculator again, 1750 times negative 3 is negative 52.5. Okay, now when I add these equations, one of the variables will cancel out. The n's will cancel out. 12n and negative 12n cancel. And I get 20 plus negative 18, so 2p equals 55 plus negative 52.5. So 55, so that's 2.5. And this is a one-step equation to solve for the number of pins, or the cost of the pins. I just divide both of them by 2. So the pins cost 2.5 divided by 2, $1.25. Alright, the pins cost $1.25. I can now use this back into one of my original equations to figure out how much the notebooks cost. So I'm going to use the first one. 3n plus 5p equals 1375. So 3n plus 5p, p is 1.25, equals 1375. So 5 times 1.25 is 6.25 equals 13.75. And this is a two-step equation. I'm going to subtract 6.25 and then divide by 3. So minus 6.25 so 3n equals 13.75 minus 6.25 to 7.5. And then I'm running out of room a bit, so let me move it over here. I just need to divide by 3, and I will get the cost of the notebook, or the cost of each notebook. So 7.5 divided by 3 is 2.5, but since we are dealing with money here, we will write it as $2.50. So when we want to know the cost, based on this information, of the pens and the notebooks, then our ordered pair, n comma p, would be $2.50 for the notebook, $1.25 for each pen. And we do want to make sure that even though we write the ordered pair, that we want to know that cost of a notebook is $2.50 and the cost of a pen is $1.25. Alright, so do try to keep in mind what we were actually trying to do here, which was solve for the cost of a notebook and the cost of a pen. And that is how you solve using elimination method.